Hello everyone, welcome to another episode of Ksa Talk Show. Welcome to another episode. Today we are going to code Emacs Lisp. Okay, so coding Emacs Lisp, here's my keyboard, Glove 80, fantastic keyboard. Search for Ksa Glove 80 review. You'll find it on my website, video review, 2 months ago. And hello everyone. And so we are going to code Emacs Lisp. So let's switch to my Windows so you can see. So Emacs, for you Emacs fans. Emacs is a powerful editor, okay? So Emacs, so let's see. Let's look at today's talk show page. So what are we going to do today? The Emacs Lisp coding, okay? So Emacs Lisp coding, let's see. I want space E. Wait, I want tab E, okay? So what we're gonna code is we are going to code a command in Ksa find text that opens all find files. So let me show you what I'm talking about. So for example, you can see here's the directory. And the pink window, by the way, the pink window shows all my command calls and keystrokes as I type, okay? I'm using a Vorak keyboard layout. Any Emacs questions, this is a good time to ask me, okay? Do you have a picture of Mao Zedong at home? Jesus Huang, the Huang Yuan from Germany is a Zoomer type, hands on 4chan all the time, and talking random shit talk. Do I have it? Why? Anyway, we're gonna talk about Emacs Lisp today, okay? So you see here's a list of directories, and let's say I want to find all files containing the word Haskell, okay? So I just call this command. You can see in the pink window, Ksa find text, okay? Type Haskell, press enter. Which directory? This one, yes. And file path regular expression, HTML, okay? Enter, wait. Yeah, okay, there it is, okay? So you can tab or arrow key to go to all occurrences and or jump through all files that occur, okay? So you can press enter and open that file. You see there's a word Haskell and showing browser, Ksa Talk Show 2019, September 7th. So we, talked about Haskell. Haskell is one of the dramatic thing. Its utility is just to mention it, the drama. Okay, Haskell and Rust. A decade ago it's Haskell. Today it's Rust. Rust, guys. Put it in the title. Okay, so what is the problem? So Ksa find. Let me show you that command. Okay, so Ksa find. Okay, describe key. Then press the key. So you can see Ksa find text is a function. In this file, ksafind.el. So that is ksafind.el. Okay, go to it, jump to it, enter, and so here's the source code. Go to the bottom, 700 lines of code. Diet jump there to go into the directory. So you can see here is a list of all my packages. Now let's delete those Emacs backup files. So Emacs, very powerful. You just press Shift tilde. Now, of course, the problem is I don't know where is the tilde key on this keyboard. I'm waiting for the light switches so I can actually, okay, tilde is now in the Shift key position, okay? So you want to delete all the Emacs backups. So you just press tilde. Wait, did I press? Oh, I pressed the wrong key. Now the keyboard lights up. Can you see it? Yes. Okay. Any Emacs questions? So there it is. You see the Emacs backup lights up and press X. Do you want to delete them? Yes. Okay, removed. Okay. So anyway, so we were on Ksa find. Here's the package. Go to the top, and you can see here is my website. Okay. Of this package, so you can pay me and you'll get it. Fantastic utility. So this package, what it does is that it does grep, find text, grep or silver or the multi-grep, whatever is fastest today. We did a talk show on that. comparing the speed, that is very fast. But okay, so XAFind does grep, but it also does find and replace, which that thing doesn't do. Okay, so, and it's all written in Emacs Lisp. So what is the advantage? The advantage are multiple. One is that it's independent from any external utility. So you work on Emacs on Mac or on Windows or on your favorite operating system, Linux. Within Emacs itself, Emacs Lisp, the powerful language, you don't need external tools. Okay, so the regular expression is using Emacs regular expression, so it's consistent. You are an Emacs user, you use Emacs regular expression. Not when you want to find some string, you boom grep, you have to type some other syntax for regular expression. No good. Okay, systematic, Emacs Lisp regular expression. So you can find and you can replace. So open the file and let's list matching lines. Let's search for the word define. So you can see here is all the functions. You have several. You can so the main function is find text, find count, which is show number of total count of occurrences. Then you have find replace text, and you have find replace text rejects. So you have a version with plain text and you have a version with regular expression. Why two? Why separate? Because sometimes when you want to find a string, and you don't want to be confused with, for example, let's say you want to find some code. There's a lot. There's backslash, there's slash, there is backtick. So if you, and there's asterisk, there is dot. So if you want to find, for example, I want to search all files containing this block of code. If you want regular expression, you have to escape them. That's very tedious and error prone. So when you want to find a text, you just call find replace text or find count. Okay, and if you want regular expression, powerful regular expression, you can use, there's a regular expression version. Okay, so that's XAFind package. If you like it, pay me. Okay, pay to get you want, and prevent society from crumbling into corruption. That's what's happening today with Google, Facebook, and all that. So you want to pay. Okay, so pay me. Thank you. And it's open source, so you can use it. And by the way, so Louis, there's update, so you can also buy my Emacs packages. For $100, I give you the whole thing, all the packages, 10 a decade of code. This update. So Louis, if you want it, Louis bought it before, so I'll send it to you via Discord. Okay, so yeah, so those of you like it, you can buy here. So Ergo Emacs key binding, no, not that one. XA Emacs, okay, so it contains about 12, 13 packages, all within integrated with XAFly keys. Okay, so that is a demo of the command. But what is it we want to do today? Okay, we are going to add a feature. So let's try again. Search for Haskell. Okay, this time let's search for Odyssey. Okay, let's search for the word Odyssey. Okay, so by the way, I have an Odyssey account. I highly recommend it. Odyssey, so to prevent YouTube corruption. So just go search for Odyssey, Odyssee, Odyssey, and you can search for Xali Odyssey. You'll find my account there. YouTube is very corrupted. Okay, so what are we going to do? So yeah, let's search for the word Odyssey. Okay, so copy that, drop into dir jump to go into the directory. So you can see there are 794 files, and let's call Odyssey. Let's search. Okay, find it. So here are multiple occurrences, and you can go down by file. So you see, and this XR find, yeah, why don't I talk about it? Because this XR find replacing pure Emacs Lisp XR find.el has several features. Okay, so within pure Emacs Lisp, but also you have regular expression version or plain version, so you don't have to escape a bunch of things. And another advantage is that you can search for a block of text, not just line. Okay, grep and silver and all the others, they are based on lines. Okay, let's search for it. Silver. Okay, I always forgot what's that package's name. Silverlight, Quicksilver, Silver. Wait, grep, egrep, yeah, fgrep, ac, silver, RipGrip. That's the one. Okay, open it, show in browser. So we did a talk show dedicated to that in 2022, January 12th. Okay, about a year ago. Why Unix grep sucks? History of regular expression, Wolfram language, string expression. Now that's interesting. That's string expression. That's a alternative syntax for regular expression. So we talked about that, and so then, today, the nerds, the elite hacker types, the Unix, Linux, they all say RipGrip, XR. What do you think of RipGrip? Have you tried RipGrip? That happens every few years. 30 years ago, it was egrep, fgrep. Okay, you guys wouldn't have any idea. So that's different. Regular expression egrep, fgrep. They merged to become grep. So when you do grep, now I don't have access to grep because I'm on Windows, and I was going to install a virtual box, but then bio. You have some bio, some virtual, something turned off. So I have to work with that. Then I'm going to have a virtual box, or I'm going to install the Microsoft Windows subsystem Linux, Microsoft Linux. So you don't have to use Linux anymore. Just install Windows, run Linux inside it. So egrep, fgrep. So I don't have grep here. I cannot show you. Do I have grep? Let's see. GCM grep. Okay. No grep. Yeah, I don't. I removed it. I installed it before, but fuck Unix, so I removed it. You don't need it once you know PowerShell. Okay, I'm starting to ramble over. Should I be focused? Finally, I've been on Odyssey for like 2 months, but the issue with Odyssey is that it's fairly technical. So Odyssey. So I'm rambling all over, okay? So who is watching? So if you guys, Jesus, 3 people. So if you guys want me to focus on Emacs Lisp, let's do that. Just tell me, okay? So let me ramble a bit then, otherwise. So Odyssey is great, it's but it's fairly technical. So it's very good for us, we like technical stuff. So, but one of the major difference from Odyssey and others, such as YouTube, Rumble, there are quite a few. You don't hear them much anymore. The Vimeo, which is an old one for over 10 years now. Vimeo, and there are several others, video platforms. But Odyssey there's one unique aspect different from all the other. Odyssey is based on blockchain. So that means any video, I'm not sure it's by choice or not, but basically it's blockchain, meaning that once posted, it's permanent, okay? Nobody can censor it. Nobody, okay, blockchain. So the blockchain protocol is Libri, okay? So let me show you, okay? So I'm starting to ramble over, so we haven't, Huang is my biggest fan. Yeah, he made a lot 4chan memes of me. Thank you, Huang. but you should do something. I mean young guys. You guys are young guys. That's fine. You guys are hanging out in college, having fun, party. But keep in mind, do something useful. Okay, 4chan will rot your brain. Once in a while it's fun, but don't live in it. So I've been branching off to several topics. I want to go back to grep and stuff, and I wanted to talk about Odyssey a little bit. So let me show you some programming blog. Okay, so I work every day, non-stop, work myself to death. JavaScript, PowerShell. So Odyssey, yeah. So Odyssey is the video platform that is based on the Libri protocol. Okay, Libri is open source. So Libri protocol is a blockchain protocol. Now, blockchain is a very kind of newish technology with significant, society changing applications, which is happening. One of the most famous example is Bitcoin and basically every other cryptocurrency, Ethereum, Monero, cryptocurrency, that's another big topic. But anyway, so cryptocurrency, they are all fundamentally rely on blockchain technology. Okay, and Libri is using blockchain technology. So blockchain basically, I can explain in 1 minute. So you have some data such as a bunch of text, so let's call that a block of text. Okay, now you can apply a function, a hash function, so-called hash function, which is a mathematical function, which basically turn this text block into a short string, usually 128 or 64 characters. But anyway, so you turn a block of text into a string, and that string is unique, corresponding to this block of text. No other block of text will have that string, practically speaking. Okay, that's the hash function. So each block of text, that's data or a video or photo, whatever, digital data or book, PDF or whatever. So each file, it's a bunch of text. You can apply a hash function to get a hash key, which is a short string to represent this text. Okay, so you have a blockchain. So you apply the hash function. You got a unique text that represent this block. Okay, then you create when you have a new data, let's say a new video, whatever, a new block of text, or can be a video file or whatever. Then you also apply the hash function, so you get a key, a short string represent the second block. Okay, but in the second block, in the block of text, you add a link, you add a reference link to the first block. Okay, and that contains, so the link will contain the first block's hash key. Okay, so let me repeat, let me make this clear. So a block is just a file or a bunch of text or whatever. You create a key, hash key of it, so that forms one block. Then when you have a new block, you also has a key, form a key, but in the new block you also add a link to the first block, a reference to the first block, by, I'm not sure how it's done, but by whatever, I'm not sure how it's done. It's a link to the first block. Okay, and that also, so in the second block, that also has the key to the first block. Okay, then when you have new data, you do the same. You create a new block, you create a hash key of it, and in the new block, it contains the key to the second block. Okay, so they forms a chain, and this sequence of data information, this sequence of files cannot be modified. Why? Because once you modify it, you modify any of these block, information, then the hash key will be different, because remember, each block has a key that uniquely represent that content. If you modify the content, you apply the hash function again, the key will be different. So anyone can tell that's not the key, something is changed. So anyway, so you have this block of blocks and they are linked in this way. So anyone who modified it, you'll be able to know. And this blockchain is distributed to everyone. It's public, okay? So it's public. So you have a copy, I have a copy, everyone has a copy. And so whenever somebody modified it, their blockchain, you can compare, these two blockchains now are different. Now you can try to generate a hash key to see which one is inconsistent, then that's a bad one. So anyway, so blockchain basically works that way. So so the functionality, the kind of the gist, the power of blockchain is that it creates digital information that cannot be modified. More correctly, is that anyone who modified it, anyone else will know. So essentially, it creates a what's so-called immutable information. You cannot do fraud on it and so on. So blockchain. So anyway, Libri is a blockchain-based blockchain protocol. Okay, and Odyssey or this video they are based on the Libri protocol. So any video you create is out on the internet permanently. Now, this is also another one point that many tech geekers do not want, because many of you, like I don't know, many of the young people anonymous, they are irresponsible shit posting memes and all that on Twitter all over. So these people on Reddit, on Twitter, on Hacker News, on YouTube, all the comments are anonymous shitposting fuckheads. These are Zoomers, the Zoomer generation. They grew up that way because the moment they were born, or everything is like that. Okay, so these anonymous people, so they may not, like this blockchain-based video platform, because they are worried about, I don't want any information to be known. These idiots. These are the people that made society worse and worse and worse. And you can't really blame them neither, because they were born that way. When they were born, the world, the Google, Facebook clickbait is already like that, and 4chan, Oh God, went into a rant. So let's go back, shall we? So let's go back. So anyway, I have an account on Odyssey. So there's one thing I'm not too sure yet. I'm still studying. I need to read up this Libri protocol. Okay. So one thing I'm not too clear is that, is it true that once you create a video, it went into the blockchain, or is that maybe you have to, for example, open this one, maybe you have to actually click a button, then it goes into the blockchain. I'm not sure which one, because that's a concern for me as well. Suppose, like right now I'm doing a video and suddenly I made a mistake. I showed my password, some important password. Then, right now I have Odyssey set up to automatically sync. So it becomes, maybe my password become permanent information in the blockchain. That wouldn't be good. And so because it's blockchain, you cannot delete it. So what is this? This needs to be redone. This is another issue about Windows stuff. Okay, so let's copy. Okay, this is the power of XAR HTML mod. Okay, so anyway, we digressed a lot. So now, that's about Odyssey and Libri. Okay, so now let's talk about, grep. anyway, we did a video on that RipGrip. I did actually speed comparison of RipGrip somewhere on my website. Let's see if we can find it. RipGrip, there it is, RipGrip. Yeah, RipGrip, the features, here's a summary of the features and whatever, and some issue with the guy. He has an obsession. He is afraid of, he refused to make RipGrip to do find and replace. To him, there's some kind of fear. He doesn't want to make it do replace but the issue is, if you don't do replace, you just do grep, then it becomes very little utility. Nobody needs your speed. Okay, for most people, nobody. There's only one Google. There's only few corporations with some petabyte 1 million files. So you don't need RipGrip. You don't need these hack to make it fast. So if you don't do find and replace, what's the point? Grep works. Grep 30 years old, grep works just fine. So anyway, back to find. So written in Emacs Lisp. Okay, so we have that. Okay, so yeah, so let's do it again. Find. Actually, we can repeat the command call. Let me show you. Okay, this is a good tip. So you can call this command, describe key, this command. Okay, repeat complex command. What this do is that it will call that command that asks you a bunch of prompt. But now you don't have to type the prompt. So let's just do it. Okay, so for example, repeat. There it is. Look at the bottom. Okay. So I just press enter, it'll find, all the words silver in this directory. Okay, so I don't have to answer each question. Silver, okay, so actually, we can do it again, repeat, okay, so you can see the command is repeat complex command. I have a tutorial on my Emacs website. You can search and find it. Okay, so let's call it again. But what's better is that I can actually modify here. So you can see I change it to RipGrip. Okay, GREP. Enter. There it is. All files containing the word RipGrip. Okay, so now, but what is the thing I want to do? I need to do. So I want to. So you can sometimes you have hundreds of files. Now I want to call a command that opens all these files. Okay, so that is actually the Lisp thing I want to do. So I already talked for 30 minutes. Hello, Benjamin, Abby. So anything, you guys, any questions? Okay, let's just start code Emacs Lisp then. Okay, so I want to create a new command that opens all the files that's found. Like in one shot, maybe 10 files, 20 files, or 100 files. Right now, I can just jump to each one and press enter to open, and go to the next one, press enter to open. But I want a command that just open them all. Okay, you cannot do it with grep, you cannot do it with RipGrip, you cannot do it with silver. Okay, so let's okay, so we need to write that command. So first of all, let's go to what? So what is this? Talk show showing browser. Okay. So now we describe key. Okay. Now jump to the package source code find. So we want to add a command here. Okay, so here's a source code for find text. We want to add a command that says open all. Okay, so let's list matching lines define. Where do you want to add it? Any comments and questions? Okay, find text. So let's just start to code. Okay, first of all, make a backup. There it is. Now, so let's copy that. Actually, it's where do I add it? So let's just add it bottom. Okay. Okay, and rename this file. What name of the file? So find open all. Okay, now write some documentation. Open all files. Okay, for now let's just say that. Okay, and open all files. So interactive. So we want to open all files. Okay, so big interactive. Okay, so actually okay, let's clear them. So that's the function we need to write. So let's try to find again. Let's search for find. Okay, so here is the output of find. They have this particular format. Each file have a separator like that. Then each occurrence is on a block by itself. You can see, and each occurrence begin with a number. That number is the position of the first character in that file, the occurrence. Okay, and so this is the output format. Now we just need to open all these files. Now, to open all these files, there are two. So here's a design issue. Do you just want to open it like anywhere in the file, or do you want to open specifically to an occurrence? Preferably, you should open at the position of the occurrence. Okay, so let's close that. Let's save this. Okay, let's save this find. Okay, so okay, yeah, I'm doing video, so it's probably very boring now. So I want to let me try to speed it up. So let's just open all files. Wait. So what you gonna how do you open all these files? So in the output, all files are delimited by these special brackets. Okay, so you can, or let's see, yeah, so they are delimited by that bracket. So there's quite a few ways to do these. Ideally, let's see, go to the bottom. Okay, so there's a lot of occurrence. Let's just search for char count. Okay, so find all files contain the word char count in this directory. Okay, so how many? So there's only one file. Okay, so let's find all files contains the word after. Okay, so there's a few files. So one way is that there are several ways to do this. Okay, so for example, let's go back to our source code. So one way is that, okay, so you see here's a source code. So one way is that when you find the file, you push the file path to a list. So that way, when you are done, you can just open all files in this list. That's one way. Okay, the other way is that you just base on the output. So for example, that's what we were trying to do. So the other way, so the second way is just at the output, you just for example, we can list matching lines by that bracket, so you can see all the lines matching that bracket. Then, so these are the files. So then we process this file, then open each one of them, all of them. So two ways to do this. Now, obviously, the first way is more efficient, because so once you find a file, you push it to a list. But if we do that, there is the question of where do you store that file path? I mean, where do you store this list? Because if you could save it to a temp file, but that gets complex because that creates something extraneous. You could, so where do you store? Or you can store, so you can store in a variable. Oh yeah, so I can actually, so let's think about that. Yeah, let's store in a temp variable. Yeah, I mean in some kind of, so let me show you. Okay, define var. Okay, let me just type define var. Okay, and define var, what's the variable you want to create? I want to say find result file. Okay, so now documentation, optional initial value nil docstring. So this is a list of the last find operation. Each element is a file path. Okay, full file path that contains the occurrence. Okay, something like that. Yeah, so that's great actually. So if you do this, every time you find a file, you just push it to the list. Yeah, then the open all will be easy. So the open all will just be, basically find file. Let me write this. Okay, map C. So map a function to this list, and for each one, what you do, this lambda is x. There it is. Okay, so this is very good. However, now there's a problem. If you do this way, then if you open up some result, after a month, this will no longer be available. Yeah, so that's the issue with this approach. For example, let's do it again. Okay, for example, let's do it. Find file, find all the words containing after. So you see, here's a result. I can save the result. Let's say xx result. Okay, save it. Okay, I can close it, go to the directory, go to the bottom, refresh. You see, here's a file. You can actually save it. Okay, close it, open it. You know, when you open it, the top line says put this in the major mark XAR find output, and that's how you get all the highlight. You can still, you know, navigate among, you know, around them. So you know, this is very useful. You know, a month after a month, you can revisit this result file. Yeah, so okay, so now let's go back. But now if you implement this find open all by relying on a variable, it won't work. You know, let's open the result. Okay, it won't work because the variable doesn't contain anything. So yeah, so I don't want to use so I don't think I want to use this approach. This is useful. This is efficient and easy, but the problem is that you open some result file, it won't work. You see, the list of files is already contained in this, you know, in this result file. Okay, so this is one approach I don't want to do. Yeah. Also, if you do this, that means you have to modify list matching lines. You have to modify several of these find and find replace functions so that each time they push the result to this list. Okay. So anyway, I don't think this is the way I want to do it. Okay. So another way, let's say open all 2. Okay, for now. Open all files. Now this way is so the algorithm would be look for format like this. Okay, that's a file path. Open them. Okay, so this is the second way, and let's do it this way. So now this bracket is actually, you know, that special bracket, you know, you can look at the name. That special bracket is called medium left pointing angle bracket ornament. Okay, so if you go to my Unicode blog, you can search for bracket, so you can see all sort of brackets there. Okay, hide hexadecimal, hide ID. Okay, so you can see all sort of brackets, or you can just go to this page, you can see them. Half of them are Chinese brackets. Very useful. Brackets has a special property that they are the only character that semantically embeds the information of a matching pair. In other words, they are matching pair. So that doesn't happen for any other character. Not, you know, alphabet, not English alphabet, not Chinese characters, but brackets. Okay, bracket characters, they are unique. They have this property. That's why it's very useful in Lisp, you know, all the nested brackets. So very useful. So now close that. Yeah, close that. So this bracket character, if we search for it, it's right here. You see, so that the variable name is XAR find file path prefix. So you have a prefix and postfix. Okay, so I'll actually copy that. So that and postfix. Okay, I'm trying to find where are my keys. Yeah, there. Okay, so prefix and postfix, that's the opening and end brackets. Okay, so anyway, how do we... No comments. Okay, so I'm just gonna code this myself then. This is something I need to do myself, lots of work. So you're just gonna text process this file. So what is the optimal way to get all these file paths? Of course, you can do list matching lines, but that's not, that's for interactive use. That's not good to call in Emacs Lisp. Yeah, and also if you do list matching lines, then you have to pass. So what's a way to... Let's look at the source code for list matching lines, okay, which is a alias to occur. Okay, it's pretty complex. Oh, okay. So list matching lines, this Lisp car da da da. Lisp. This is the most idiotic thing about Lisp. So list matching lines, how does it work though? Let's see. And define, so it relies on other functions. So the list matching lines is only like 10 lines of code. So it mostly rely on many other sub-functions. So start and in region buffer, make overlay, start and overlay, occur original point, list OL. So what is OL? Make overlay. Pretty simple. So actually, so you see here, this is the main body. Occur1, internal function. So let's go there. Occur1, yeah, occur1 is the real list matching lines. So you can see, copy it, new buffer, paste 100 lines. Okay, now make it XAR Emacs Lisp mod. So occur1 is buffers in a list of buffer or overlay. So this is kind of the meat. With current buffer, occur buffer. Yeah, that's not what we want. That's not what we want. Too complex. It's doing too many things. And occur engine. Okay, this is the real meat. Perform normal occur engine. So you go to there. Occur engine. So it goes through 2 layers of indirect call. So occur engine is the actual list matching lines, something like that. Yeah. Oh, interesting. So that means I can actually also use this occur engine, regular expression, buffers, output, out buffer, lines, case fold, title, blah blah blah. You see, no documentation. I really hate that. Most programmers, they don't document. The Emacs, Emacs is generally very well documented. I mean, I'm talking about the inline documentation. But even in Emacs Lisp, most internal functions has no documentation, such as this case, no documentation. But every of my command are always fully documented, elaborately. That's just how I roll. So anyway, occur engine, okay, we are not going to use this. We are just looking at this for curiosity. Okay, so close it. Okay, close it. So now we are back to our problem. We just want to get all these lines so we can. Okay, let's do it quickly. Let's okay, we need some variables. Okay, so let declare local variable and list. Okay, so list is a path, a bunch of, this is a result path we want to open. So what we can do is that this is Emacs Lisp coding, so excursion, save excursion. So we want to start to move the cursor. So when the command done, we want to return the cursor to wherever it is. So that's why we do save excursion. Okay, so that means whatever we do here, when it's done, it'll return the cursor position to whatever it was. Okay, then we go to chart point mean, go to the beginning of the buffer. Then we search forward. We search forward for the opening bracket. Okay, so we need a while statement. While, not when. While, okay, while search forward, we search for the opening character of the file path. So optional bound nil, no arrow true, count, we don't care. Okay, so once you find it, you don't want to replace, but what you want to do is you want to save position. Okay, so we need a variable xp1, xp2. Those are temporary variables for cursor position. So once you find it, set xp1 to point. Point returns the current cursor position. When you do search forward, you'll move the cursor there. Okay, any comments and questions, post it. Okay, and so then we search forward again. Okay, then search forward for the ending bracket. Okay, then we bound nil. Okay, this time no arrow is true. So if you cannot find it, that means you got a problem. It should always happen. Okay, so when there's error, return error. Okay, then you search forward, then set xp2 point -1 actually. So okay, because you want to move one cursor back. You want the inside. You don't want to include the brackets. Okay, so that's P1, P2 is the beginning and end position of the file path. Okay, then what you do is you get you buffer substring no properties. Okay, xp1, xp2, that will return the string between those two positions, and you want to set it to actually you don't want to set, you want to push new element, that's a string, the path, and push it to X path. Okay, so we are populating this a bunch of file path. Okay, now prettify the code. Okay, fantastic. So far so good. Yes. Now let's see. So you got the path. So once you're done, where is the while? So while search forward, search for the beginning, and search forward for the end. When you found it, push to the path, then repeat. Yeah. So when you are done, this X path should be populated. Then what you do is you just open them all. Okay. So map char, map a function to all these file paths, and each one you just find file X. Okay, so that is, I think that's it. That's it. Fantastic, we are done. Comments and questions posted. Okay, cool for school. I remember your name. Where's your glasses? Have you not been in choir? I have not been in choir. I'm a technologist. I'm a beautifier. I'm concerned about my looks. So I wear contact lenses. There's an upgrade in my life from the poverty of poverty to now I can wear contact lenses. Okay, so back to Emacs Lisp. So I think that's the function we want. Let's double check one more time before we run it. I think that's it. Let's evaluate it, and so let's clean up the code a little bit. Let's remove those, clean up the code. So eval the buffer. Now Emacs know about our new function. So now we call the command find text after. Do it. So it now it contains all files containing a word after. Actually, we don't need to. We already have the file here. Close it. Go to the diet. Open it. Okay. So you see, we found this before. Here's the result. Now all we have to do is meta-x. Call that. Okay. Now first of all, how many files? All these files. Okay. So meta-x find open all 2. Enter. It works. It worked for the first, So now let's list list buffers. So you see, it opened them all. So now we can close. Fantastic. Close these two. Close Xafly keys. Close. HTML mod. Close. Okay. Close. Now let's try something else. Let's go to Talk Show. Okay. Now let's find find text Haskell, HASKELL. Enter in Talk Show directory .html files. Enter. Okay. Wait. Okay. So you got all these files, right? Now you can do list matching lines. So you can see there are 28 files. Okay, close. Now call find open all. Do it. Okay, it's a bit slow because when you are open, tens of files, every time they open, the major mod gets loaded, and they started to do syntax coloring. That is very slow. Okay, so now let's Lisp buffer. There it is. Fantastic. Let's see XR Show files. Fantastic. We did what we wanted to do. Fantastic algorithm. So now we keep pressing. We want to close them all. So Lisp buffers, iBuffer. Okay, use iBuffer. Let me show you. So go to Emacs blog. If you like my stuff, buy it. Okay, go to Emacs tutorial. Here's where you can PayPal me to get it. Okay, support me. Then you go to Emacs tutorial. You go to file section. Then there's a buffer section, Lisp buffers. Okay, and you want to use iBuffer. Okay, you don't want to use the default Lisp buffer, iBuffer. All the details are there. Just search for XR Emacs Lisp buffer. Okay, so now Lisp buffers. So you can see all these XR talk show files we opened. We press D to mark them for deletion, meaning remove them from, meaning close them. Okay, actually this is a bit confusing. It's not actually deleting the file. So now you press X. It asks you, really kill 25 buffers? Yes. Okay, answer yes or no. Yes. Okay, you see now we close them all. So except, so anyway, that's it. Okay, back to Emacs, close, Emacs blog, close. Here's the XR find output, close. Okay, that's it. We did what we wanted to do. Fantastic. Anything else? That's it for today. Coffee. Four people watching. That's it. Thank you guys. Have a good day. Bye. We close down in 1 minute. Fantastic. Fantastic. Now let me show you my glorious face. Okay, we shut down in a minute, and let me do some cleanup of my files for today's talk show. So switch to next. Yeah, so we need to go back to, okay, show the pink window. Okay, close that, show the pink window so you can see my commands. Now go to describe key, press, jump to the file, go to diode, go to the bottom, open this result page, delete, and close. And now the new function is here. Now we don't need this define var anymore, and we don't need this anymore, and rename this to XR find open all files. And also make the documentation more complete. Must be called when in the result page. Okay, this command works only when the result page. Okay, so that is actually pretty good. Actually, I'm a little bit surprised. Actually, it's so short and functional. So now we just go to the top. There's a version. Let's update the version. 9, version 9, new feature. Okay, and now let's call. There's a fantastic. Let me show you the command. okay, there's a vcdiff command, so you don't need magit, okay, magit. So press the key so you can see the difference, the modification we made today to this file compared to the git. So you can see, so this is the file we added, this is a feature. So now let's write a feature documentation, okay, new buffer, paste, so new command, okay, that would be the git message, cut, drop to E shell, git status, okay, then git, before we do that, you see right now we are in XAR Emacs, all my packages. Now, however, XAR find, it has its own dedicated git separate from XAR packages. So we open that, we want to copy this, our change to the XAR find's own git repo. So you can watch the pink window, see the command I called to copy it. So press. So you see the command I called is XAR sync x Emacs packages. What it does is that it copies the current file to the associated git repo of that file. So now if you do direct jump, you can see now I'm in the XAR find git. So you can open that, then now you do vcdiff, you can see basically the same difference, okay? So here, now you go to E shell, close this instance, do again, now you git status, okay? Now you git add XAR find, yes, and what do you want to say? Git commit, okay, what's the commit message, okay? New command XAR find open all, enter, fantastic, okay, close, now back in the XAR package directory. So you need to do the same thing, git status, git add, do that, okay? Now git status again, there's some change here. Oh yeah, the repeat key, I made that change. Okay, anyway, bye guys.